So we are looking at our 2-1 notes today, and we are solving linear inequalities and doing some practice with it. So just to remind you about graphing inequalities, you're going to use a closed circle if it is less than or equal to, greater than or equal to, and you'll use an open dot or circle if it's less than or greater than, just like you would use a solid line and a dashed line. So closed circle on your number line, open circle on your number line. We are going to be using interval notation. So interval notation is using parentheses if it's less than or greater than, and using the square brackets if it is less than or equal to, greater than or equal to. All right. And remember, if it's negative infinity, it has a parenthesis on it. Positive infinity has a parenthesis. So again, not included would be parentheses. Included would be your brackets. Okay, so first things first, we're going to go back to some basics, and we're graphing x is greater than or equal to 8. So open or close circle on the 8. Close circle. And then since it says x is greater than, which way would you shade it? To the right or to the left? To the right, because the numbers are getting greater. Don't be lazy. Make sure you show your little arrow shaded. Okay. What would be the interval notation for this? Interval notation always goes from low to high. So the low is 8. What's the high? Okay. What goes on the 8? A bracket, and the infinity is a parenthesis. Okay. Now, this one says a is less than -1. Open or close circle on -1. Open, and then determine where to shade. A is less than. And do you remember that less than looks like an L, if that helps you? So we should shade to the left because the numbers are getting smaller. Okay, now I have one issue here. I'm just going to add one in here. Let's say I have 2 is greater than A. How would you graph that? Add that in there. 2 is greater than A. And your number lines don't always have to start at 0, but you need an even interval on your number line. So when you're making a number line, you need to show at least 3 numbers, and the one that is important is that 2. Open or close circle on the 2. Okay, take a minute and decide which way to shade. It says 2 is greater than A. 2 is greater than A. Are you shading left or are you shading right? So if you read 2 is greater than A and you see the greater than symbol, you might want to be shading right because you're seeing greater than. But 2 is too big. I think if you have it answered like this, you should rewrite it to say A is what? Less than 2. So if you were telling me to shade left, you were correct. So if a teacher has ever told you to shade whichever way the arrow is pointing, that rule does not apply unless your variable comes first. So my problem is we get to the end of the problem, we get it all right, we see the greater than symbol, and we shade greater. I think it's worth your time to rewrite it so you can think about it being less than. Got it? Yeah. I should also be able to pick any point that is shaded, like 0. 0 is less than 2. If I pick something above it and I test it, 2 is not greater than 3. So that could also help me to test a point. Okay, go back to number 2. What is the interval notation for this one? The low is negative infinity. That has to be first. The high is -1 with a parenthesis. I almost messed that up. Okay, now that's like the final answer. So we're going to back it up and we're going to solve inequalities. We're using our inverse operations and the order of operations to solve inequalities. Reminder, if you multiply or divide by a negative number, what do you have to do? You must flip or reverse the inequality. You must switch the inequality symbol. All right, we'll talk about why in a minute, but we'll come back to that. So we are going to do 3 things. We are going to solve, we are going to graph, and we are going to write it in interval notation. All 3 pieces. Got it? All right, I'm going to get in here a little tighter. Okay, so here we go. You don't have to draw the line here, but I am going to. Cross the line, change the sign. First thing I'm going to do is clean it up. I'm going to distribute that. So I have 3 minus 4m minus 1. And while I'm over here, I'm going to add like terms. So if I don't cross the line, I don't change the sign. It's just 3 minus 1, which is 2 minus 4m greater than or equal to 5m minus 25. Okay, at this point, we could all do things a little differently. You could move the 2 over here. You could add the 25. I'm going to stick with moving the variable first because I think it helps me to find my variable. And I'm going to bring this over to the right. So minus 5m minus 5m. That should cancel it out. On the left, sorry, I moved it to the left, I have 2 minus 9m greater than or equal to negative 25. It's very important that you keep the left and the right separate, and you can't just move them around. Now that I have that, I want to leave m there and get rid of the 2, so I'm going to subtract 2. So the way I did it, I have negative 9m is greater than or equal to what? Negative 27. Now, how do I get rid of multiplication? I should divide by negative 9. Okay, so here it goes. The negatives cancel, the 9s cancel. I'm left with 1m or m, but I divided by a negative, so what do I need to do? Yes, so when I divide by this negative, I need to flip that sign. So this should be less than or equal to, and a negative divided by negative is going to be a positive 3. Okay, why am I flipping the sign? Well, one, because you've been told that rule for how many years. But why? If you think about negative 27, it'd be way down on the left of this number line. You started with a negative number, and when I divided by negative, it flipped it to the right side of the number line. Now remember, if you look at this, 10 is greater than 9, isn't it? But over here, negative 10 is less than negative 9. See that mirror image? So if we're flipping from the negative side of the number line to the positive side, we've got to flip our inequality to follow that. So that's why you're doing it. This is my answer as an inequality. I need to graph it. So open or close circle at 3, closed, and shading left or right. It says m is less than or equal to, so we should be shading to the left. Now, you could have solved this differently. We should get the same outcome. All right, interval notation. What's the low? What goes forever? So negative infinity 2, 3, and what goes on to 3? Bracket. Okay, so let's check out the next one. Take a second, clean it up, watch your signs, and I only flip it if I multiply or divide by a negative when I'm moving things. So we are going to show our work. I'm going to bring everything down. I'm going to distribute this. Watch that second negative sign. This little line is not necessary, but it might help you. This is one where I'm definitely going to bring the 4p over. Then the p's on one side and it's positive. You don't have to do it this way, but I have a habit of moving the variable first. Sort of cleans things up. If you're comfortable, you can move the 52 at the same time. Okay, I'd be moving them both at the same time, save myself a little bit of time, but it's whatever you're comfortable with. So I'm going to subtract 52, cross the line, change a sign. I've canceled it. I get 8p is greater than what? Negative 60. And when I say cross line, change a sign, this is multiplication. What's the inverse of multiplication? So I'm changing it from multiplication to division. Now, I can leave this as a fraction. Did I multiply or divide by a negative? No. So I started with a negative number, and I'm keeping my negative. And I could reduce this, and it'd be 30 over 4. But I can't picture what 30 over 4 is in my head. So you can just divide 30 by 4, and what do you get? Okay, so P is greater than negative 7.5. Now, if you were doing this in Delta Math would want a reduced fraction, not a mixed number, not a decimal. But this negative 7.5 helps my brain graph it. Open or close circle. Okay, guys, hit negative 7 and go a little further. It should be between negative 7 and negative 8. And then which way do you want me to shade? To the left or to the right? It says P is greater. So shade to the right and show with the arrow. And then interval notation. The low, I'm going to write open because mine doesn't look open. The low is that negative 30 over 4 or negative 7.5 with the parenthesis, and it goes to positive infinity. All right, flip it over. Now we're going to start building. This was the basic. Got it? All right, now we're going to get into compound inequalities. So compound inequalities is when you have two or more inequalities. So if I write something with the word or, we're going to focus on or. This is an or statement. Okay, let's compare x and negative 3. Well, it's shading to the left. So x is what compared to negative 3? Less than or equal. Or it starts and it compares 1. Is that, I think that's, oh, it's supposed to be an open circle, guys. Okay. It'd be very clear like on a test. Let's compare x and 1. X is going to be greater, and that should be an open circle. All right, that's how you'd write it as an inequality. How would you write this as set builder? Or not set builder, interval. The low is negative infinity. We should start there. It stops at negative 3 with a bracket. And then how do I put the word or in interval notation? I put a U. What's that U stand for other than the word or? Union. Yep. Okay, then we're going to start at 1, but it's not included, and go to positive infinity. So if it's an or statement, it has two separate intervals. We can physically see there's one down there and there's one up there. So you have two separate intervals. Got it? All right. Now, these actually say the word or. So to solve or inequality, solve each part individually, and then we're going to use a number line to finalize our answer. All right, so here goes nothing. We have a fraction. So how am I going to deal with this? We're going to do two separate problems. Okay, so focus on this one. How do I deal with that fraction? I need to get rid of that divided by negative 3, right? So how do you get rid of division? Okay, when we multiply by negative 3, we are not distributing it, we are canceling it. Okay, so this leaves me to multiply both sides by negative 3. Now be careful here. 8 minus x is what drops over. I multiplied by a negative, didn't I? So you better flip the inequality, and then negative 5 times negative 3 is 15. Okay, I'm going to leave x where it's at, and what should I do now? Subtract 8. But what's left on the left here? Not x, but negative 1x or negative x is greater than or equal to 7. So it's only if I multiply or divide. I can add and subtract, but I need to get rid of that negative 1, don't I? So what? Divide by a negative 1, and I end up with x is less than or equal to negative 7. All right, I'm going to hold off on graphing for a minute. Now we need to solve the other one. Okay, what do you want to do here first? Subtract 5. Okay, get rid of that 5. So I'm left with negative 3 halves. Don't lose that sign. X is less than negative 6. Good? Now, this is negative 3 halves times x. And how do we break up multiplication? We break it up with division. You have a calculator, so yes, you could divide by negative 3 halves and divide by negative 3 halves. But instead of dividing by a fraction, what do I want you to do? Multiply by the reciprocal. We want to start using that rule to make our lives easier. And so I keep the negative sign, but I flip the fraction. So multiply both sides by negative 2/3. First things first, I multiplied by negative. I don't want to forget to flip my inequality. The negatives are going to cancel. That's 6 over 6, or they cross cancel, and we get just x. Negative times a negative is a positive. Yep, you can throw it in your calculator, but let's look at this as a fraction. That'd be 12 over 3. Multiply the tops and bottoms, so I get 4, or cross cancel, and that negative 2 times negative 3 is 4. All right, there are my two answers. X is less than or equal to negative 7, or x is greater than 4. Now, sometimes we're going to have special cases, so I want to make sure this works. If you look at my number line and it says x is less than or equal to negative 7, I'm going to test it just above. So here would be a closed circle, and I would shade to the left, and x is greater than 4 would be open. This looks like a typical OR statement where they go two different directions. It's down here or it's up at the top. So that's good. I'm going to grade what's on your final number line, but like I said, there will be some special cases, so that's why it's important to do this above and test it. So I will be grading what is on your number line. Got it? I know you probably had a teacher that might have said graph above it. Anything above it is you testing it. What I'm grading is on it. All right, interval notation. The low is -10, and it is included. Not -10, what is that? -7. Let me try that again. Okay, and it goes, I'm sorry, guys. What's the low? -infinity, and it stops at -7 with a bracket, and this should be a, yep, that was pretty bad. And then union, and it starts at 4 and it goes to infinity. All right, I got off my game by pausing. All right, are we good? Hopefully you did better than me. All right, go to this one and solve them. So two separate ideas. I'm going to subtract the 8 first. So -3y, keep the less than or equal to -15, and now what? Divide by -3. So that is going to flip my sign to be y is greater than or equal to 5. I'm going to put my word or here because that is important. And then we're going to solve this one. So I end up with 10y is less than or equal to -30. Now I'm dividing by 10. Should I flip my inequality? No, it was a negative. It's going to stay a negative. So y is less than or equal to -3. All right, take a second and graph that. Remember, open or close circles. So here, y is greater than or equal to 5 would start here and go up. So it's not going to be a special case. They're going to go in two different directions. Y is less than or equal to -3, close circle, and it's going to shade going down. Interval notation, I can get this right this time. The low is -infinity. It stops at -3. Union, the low on this interval was 5, and it goes to infinity. Okay, always low to high. Got it? All right, now we're going to change gears, and we're going to do and statements. Good? Okay, so in an and statement, I could have two separate things. X is greater than -4. Because look, if you start here at 4, doesn't it go above it? But it doesn't go on forever. That's why I have the word and here. X must be less than 3. And these are both open circles. So if you think about this, if I say X is greater than -4, that'd be you doing this and going on forever. And I say X is less than 3, that'd go here and it would go on forever. But the word and means they have to happen at the same time. So if I would collapse these graphs, do you see that it would cut off here and just be everything from -4 up to 3, but we don't include them. Okay, so I can write it like this, but you might also see it written as -4 is less than X, which is less than 3. This is also an and statement. Can you see it? -4 is less than X, and X is less than 3. So you can see an and statement written with the word and or written as a compound. You're going to see this more often, okay? Interval notation. Well, the low is -4 and the high is 3. Guys, there's no infinity symbols here. A lot of you are doing -4 to infinity and then infinity to 3. There's nothing in between. We know it starts at -4, it ends at 3. Okay? All right, so this is what I was just talking about. The solutions to an and inequality fall between two endpoints. So you're looking for the overlap on an and statement, where an or statement is often a split unless it's a special case. So how would you write this as a single inequality? It says X is greater than or equal to -2. So read it from the low. -2 is less than or equal to X, and X is less than 5. So do you see how I use the X for both of them? There is no other way to write this as a compound. if I cover this up, -2 has to be less than 5. Got it? I cannot write an or statement like this. Or statements will always be separate because the signs go 2 different ways. Okay, if you read this, the and inequality is written without the word and. It means you have to include each piece. So if you go through, do you see how this is an and statement? You guys have 2 ideas here. Here's one idea. -2 is less than or equal to a minus 1, and a minus 1 is less than or equal to 6. This compound inequality has 2 pieces. -2 is less than or equal to a minus 1, and then the other one, repeat what's in the middle, a minus 1 is less than or equal to 6, because we are going to break down our problems. Do you see what I'm doing there? You've got the first part, that's one problem, then you've got the second part. And so this center goes on both pieces. Now, you'll see some videos or you'll see some teachers who will just add one here and add one there. I'm okay with you not breaking it apart, but we often make mistakes. So here we go. This is an and statement. You don't get to pick and or. It will tell you or, it will tell you and, like this one tells you and, this one we have to understand as an and statement. So I am suggesting we split the problem, we rewrite it. So I'm going to start with 1, -5 is less than or equal to 12 minus x over -2. And then I'm going to start with the other problem. So that center is repeated there, but now we're comparing it to -2. That is an important idea. So the center is being shared by both pieces. Are we good with that? Okay. Now, you can't let the fraction bother you. I need to get to this x. I have to get rid of that division first. What's in the numerator is like it's in parentheses. So I'm going to multiply by -2 to both sides. And that gives me positive 10. What do I need to do? Flip my inequality is greater than or equal to 12 minus x. Okay, now I need to get, I'm going to leave the x where it's at. You can move it. I'm going to leave it. I'm going to subtract the 12. So right now I have -2 is greater than or equal to -x. Well, now what? I'm going to divide by -1. Now, you have to keep your left and your right separate. I know if this is an equation, we just say, oh, x is 2. Over here, I get a positive 2. I have to flip my inequality because, again, I divided by a negative, and I'm going to keep my x here. Now, if you're thinking about graphing this, we would rewrite this as x is greater than or equal to 2. All right, let's do the second one. I'll put my little word and here. On the other one, same idea. I'm going to solve it the same, but I'm going to get a different number. Multiply the 2. It's not distributing, guys. That -2 is canceling. So on the left, I get 12 minus x is less than, oh, no. It's what? Greater than positive 4. I'm going to do the same thing. Subtract 12. And I still have a -x, but it's greater than -8. Now what? Same deal, divide by -1. Okay, so I end up with x is less than 8. So we did have 2 sign flips there, right? Okay, so if I'm going to graph this, I'm going to show my graph above. I don't want to assume it works, and I'll show you later why. X is greater than or equal to 2 would be a closed circle on 2, and we would shade going up. X is less than 8 would be an open circle, and we would shade going left. Now, this is an and statement, so where are they both true? Starting at 2, going up 2, but not including 8. So the 2 was included, and it's part of this graph. The 8 was included here, but it's not part of that. And means they have to both work at the same time. Okay, a couple things. This answer is acceptable. I would not mark it wrong as an inequality, but you could also have kept this as 2 is less than or equal to x, which is less than 8. So that answer is another one that you could see. How do you write this in interval notation? The low is 2, which is included, and the high is 8, which is a parenthesis. If they didn't overlap, then there'd be no solution. You have to find the overlap for and. Okay, go ahead. This one's already separated for us. We have two different problems, so let's take a minute and solve it. First thing I'm going to do is subtract 1. So 2w is less than or equal to 10, and then what? Divide by 2. So w is less than or equal to 5. I did not have to flip anything. All right, this one, subtract 1. This cancels, but I'm left with a negative 5w is less than 40. And I'm going to divide by negative 5. And I get w is greater than negative 8. We had to change the sign, right? Word goes in between here is and. All right, let's look at our number line. W is less than or equal to 5 would be a closed circle, and then we would shade everything to the left. W is greater than 8, negative 8 would be open and shade everything to the right. So if this is an and statement, do we have overlap? Absolutely. So it starts here, it ends at 5, and everything in between is shaded. Okay, now I'm going to say this again. The word and has to be in your answer. If you were doing this on Delta Math, it's not going to want the word and. Delta Math is going to want you to rewrite it with the low number, negative 8 is less than w, and w is less than or equal to 5. That is the answer you're going to see more times than not, but it means and. Interval notation starts at negative 8, but it's not included, ends at 5, and it is included.